Hi everybody, so I'm always making generators of all kinds and I'm really interested in exploring that, but then I thought, well, what about somebody who just wants to make a generator for maybe something like their wind turbine and they don't have a motor handy? What could they do? So I went down my local store to see what was just lying around really that could make a pretty decent generator for a wind turbine home project, and what I've done is I've got some of these. These are M10
Okay, so
bolts.
I've got 8 bolts, 70mm M10s, 16 nuts to fit them, 16 M10 washers, and 8 bits of heat shrink 4 centimeters long. On with the washer, on with the heat shrink, another washer, and then on with the nut. And then heat shrink that. There we are. It's curious how cute they are, even though they're just bolts covered in heat shrink. The only reason these are yellow and these are blue is that I ran out of yellow. Now what we need to do is wind those with some wire, and this is 0.35mm enamel wire, and we're going to wind them. The only thing to remember is to wind them in the same direction at the same start point. So we'll start here, wind in that direction, and every single one needs to be the same. Now you can wind them by hand, you can wind them in drill, or you can wind them in a lathe.
So we've got 8 of those. Now, you can either count the number of coils if you want to, or you can just wrap it and then weigh them, and when you've got the same weight of copper on there, you've got the same turns on there. Notice that I had one direction of turning, all began the same way, all finished the same way, because these get connected in series, which means there's essentially an input and an output. It doesn't matter which one it is, but you always connect the input of one to the output of the other, and you do that round in 8. That'll make sense when we connect these up, and that's why we took such care to know which way round it was, where we started, where we finished, and therefore that's the input, that's the output, and we'll connect those up in series. Now we need to mount those on something, and for that I've got some wooden discs I cut from a bit of plywood. In fact, I've got 3 wooden discs. I've marked this out because we're going to put 8, they're marked at 45 degrees. I'll drill some 10mm holes, and that's where they'll bolt onto. I'll also drill some holes here and here and here, so we can have a double layer like that to make it stable. And then in the centre, I'll drill a 20mm hole so we can put a bearing in this section of it. So let's get that done. So we've drilled out our plates, now all we do is bolt the coils in those inner positions. Okay, so that's it all bolted together. Now all we've got to do is solder these wires together, and remember input to output, which is really easy if you've paid attention to how you wound it. So just twist them together and then we can solder them together. Okay, so I quickly knocked this up. It's just a disc of wood, and I've drilled it out for some magnets. These magnets are 0.5 centimetre by 1 centimetre across, and so I've got 8 of these and 16 of these, and then I've stuck a bit of 8mm bar in the centre, and the only other thing I've done is put this little disc on here to make it look pretty. That's it. So I didn't bother doing much in the way of how to make that. It's, I think, self-explanatory, but I do have this. It's a bit of aluminium, 10mm outside, 8mm inside, and that slides on my 8mm bar like that and creates a spacer, because we don't want the magnets touching this. But when the spacer hits this bit here, sorry about that bit here, which is the bearing, then this whole disc will be lifted a little bit off. Now we slot that in there and we're ready to go. Just like that. Okay, I've attached a drill to give it a go and connected it to this LED lighting panel. Now this panel's turn-on voltage is about 20-25 volts, pulls about 100 milliamps or so. Let's spin up the drill and see if we can get that panel to light. There you go! That's awesome! There you go. 20-25 volts, 100 milliamps, couple of watts. Not bad when you think a couple of watts is what was more or less was going into it. Now, somebody said, do you need to run it with the drill? No, obviously not. I've done it with the drill so you can see the generator portion actually working, but of course you would use another prime mover, which is why this bit is here. This bit is meant to take something else. Of course, if we take something like this, then we can bolt that on and make that a direct wind turbine, and it would be like that. But we could equally make it a HAWT by sitting something on top of that. We could equally make it a water mill if we wanted, and if we wanted, we could actually put some of our belt around here and make this just a great big cog and drive it from something like, I don't know, a Stirling engine, a steam engine, something like that. It's a generator meant to go in a whole host of things, because I now want to do something with it, like make a wind turbine, and this bit juts out just so we could demonstrate it actually working. But not bad for a couple of bits of scrappy plywood and some bolts I grabbed at the local store. So making something like a generator, well, you can do it out of all kinds of things. That one works really quite well and was made from bolts and plywood. A bit of axle extension we've got here. It's a bit of 8mm steel bar going through, there's a spacer, going through exactly the same way the other one did. Incidentally, those magnets are set at 22.5 degrees apart and go north, south, north, south, north, south. Something I forgot to mention, there are N35 neodymium magnets as well. Anybody remember this thing? It is the 3D printed Ugrinsky wind turbine serpentine coil that we did in video 1748. Now, Nils Desperandum, boys and girls, you don't have to do it this way. I also did a handmade version, and I made a Savonius type rotor out of this stuff, which is gutter pipe, in video 1312. We've got two major components, our wind turbine bit, and again, you've got choices on this. I have a 3D printer, so I printed this serpentine Ugrinsky. If you don't have a 3D printer, then you can make the Ugrinsky by hand, or if you don't fancy doing that, you can chop some guttering up and glue them on circles and you'll make a pretty reasonable Savonius. So there's lots of ways of approaching this. I'm going to use this bit, don't have to. Now, what I do, and the reason for this extension piece, is this goes back exactly the same way that it did in video 1797. And this slots straight on there. Ta-da! Now we have our wind generator, which is a Ugrinsky serpentine wind generator on our Thunderbolt. Sorry, we have a wind turbine on our Thunderbolt generator. And of course, all we've got to do now is take this outside and see how it does. Okay, so you might have noticed that it worked just as well in that orientation as it did in that orientation, and of course that's the joy of this kind of turbine. They work in any direction that the wind blows, and that's why they're great for urban environments where your conventional bladed turbine is really going to be pants. These do really well, which is why I like these kind of turbines. Now, one of the things about making generators that people hate, and me included, is this bit, winding these coils. Winding coils, well, it's time consuming, it's difficult, and you need to get it right. Incidentally, people usually count number of turns, but if you remember your Lorenz's law, then EMF is equal to BL sine theta. B is the strength of magnetic field, hence that would be improved by N50s or whatever they are instead of N35s. L is the length of the wire that's in that field. V is the velocity, the speed at which it travels, and sine theta is the angle the field lines make with the wire when they cut it. Those are the things that that govern the voltage that's being generated. So number of turns actually isn't that important, it's length of wire. And there are several ways to get to length of wire without actually counting the turns. One way is just weigh it. This copper has a weight that's the same per metre or per centimetre. If you weigh it and they weigh the same, you've got the same amount of copper on, same length of wire. The other way is to take the resistance. They have a fixed resistance per metre. So if all the resistances are the same, you've got the same length of copper on. So you don't need to count the turns, but people get obsessed by number of turns, and of course you have to turn them. So that means putting them in a drill, or putting them in a lathe, or spending hours doing it by hand. So this is always an issue. Now, we've done quite a lot of work on different coil winding designs, and it occurred to me that maybe, if we just put the bolts in and then wound one big coil, we should get a result out of it. Now, I don't know if that's right or not, but I tell you what, I'm going to give it a go. Now what we need to do is replace those with their original bolts. And like I said, it was M10 covered in heat shrink, though you could equally use electrician's tape, and when we do 8 of them, that's what they're like. And that really is just a bolt with a bit of heat shrink right there. The heat shrink protects the wire from the thread, which is a bit sharp, and so the first few turns it might cut through the wire. So a bit of heat shrink or a bit of electrician's tape. And then we pop those straight back in there. Like that, and I've stuck a bolt through the centre, so now we can put it in something like a drill or a lathe and wind that single coil. And that's the coil wound. Now, I haven't put a ton of wire on here because obviously I'm testing it. I have no idea if it's going to work, and I don't want to waste all of that wire, but I've put some wire on there. And remember, EMF equals BLV. Volts is dependent on length of wire. More wire on here, more volts. But first of all, let's see if we get something. Now what I need to do is put this back together as we made the Thunderbolt. Okay, that's it together. Now all we got to do, of course, is spin it up and see if it gets anything out of it or not. Okay, put it in the vise to make it easier for me. Got a drill on the back here, and I've got the voltmeter right there so you can actually see it. I can't, so I'm going to spin it up and we're going to see what we get. What we got, Lou?
5.2 volts!
That's madness! Okay, that's madness! If you think about it, I've just spent the last 3 videos telling you that if this wire goes in this direction, it'll generate zip. And of course, normally, that's perfectly true. But in this arrangement, we can get this to actually generate, which is incredible. Now, obviously, I lashed this together because I had no idea if it was going to work or not, and there's a ton of improvements that can be made to something like this, and yes, I'm going to make some of those improvements, because of course it's on bolts, and so this huge gap of wire is getting no magnets at all. Well, actually it is, but there's a little less than where it's touching the bolt. If we do something like flat plates or rounded plates, I mean, you know, it's just 100 things come to your mind, and one of the most astounding things about this is that single coil wound that way, which normally shouldn't generate anything, which is a huge problem, of course, because that is the same direction of coil and produces absolutely zip, and that is the way most motors are made. We make it like that, suddenly this coil wound round here can generate pretty well. So I'm going to build another version of this in metal and call it Tiny. So let's make some metal discs. Got here is some 3mm thick mild steel plate and a HSS hole saw. Let's cut out some discs. It's about 50mm, I think. Now we've got our discs. I've marked them off for 12 4mm holes going around the centre. Let's drill those out. Okay, now we've got that, let's thread those holes. What I've got here is a load of coach bolts. They're M5 and that bit's smooth, so I'm not going to have to cover them in electrician's tape. And we can put a bolt on them, a nut on them, screw them in our threaded holes, and a nut on the bottom. And we do that with all 12. And that's what we get. We need 2 of those. So I've wound my coil on my bolts, and I've also put a bearing in the back by gluing a bit of plastic on and putting the bearing in the back because I want this to be quite compact. This is the rotor that I made in 1796. All it is a flat piece of plastic, and there are some neodymium magnets in there, N35, 3mm thick, half a centimetre across, and they're arranged north-south, north-south, north-south. There's 24 of them. You'll notice there's 24 of them. There's 12 of these. Because this actually is operating like an alternator. So when all of the norths are pointing at that, it becomes north. When they move and all of the souths point, becomes south. So it just flops between north and south all of the time. That gets a little sort of sleeve on it so that it won't shoot all the way through, and then we pop it on there and it becomes one half of our generator. But of course I have another coil to go on the other half, and they will go together like that. However, this one will be offset by 7.5 degrees to that one, because every 30 degrees there's a block of metal. If I offset it, then it'll go bang in the centre and we'll have an offset. That should help reduce cogging. Anyway, all we have to do is slide those two together, and then we should have a working generator. That bit with a couple of sleeves, it slides in there like that. That bit then obviously slides on the other side like that, and it's sleeved so the rotor is away, and that's what it looks like. Now all I've got to do is put that in line somehow, so I've made a couple of little angle brackets to bolt on the back of my stators. Bolt that down. That's it finished. Okay, there it is finished, and it has really reduced the cogging having the two coils on either side. Incidentally, it's to do with the magnets and the offset, clearly. And the whole point of this, of course, is it's easy to build. I made this with a pillar drill, and that's the point of it. I'm not claiming any wonderfulness about it. It's just really easy to make, to perform actually quite well with a minimum of tools, and I think that's kind of important, and also a minimum of work. This was really easy to turn. Anyway, I guess we all want to know if it produces something, so let's spin it up and see. Okay, let's give this a go, spin it up and see what we get. Luke, I can't read it, Luke. What's it saying?
100, 120,
How much?
150, 120.
And off. Okay, so not bad for such a compact little thing, was it? Now, let's just say the whole point of this is you can make this at home with a pillar drill and some bolts and a pocket full of dreams and a handful of hopes. What I've done is I've taken the Mite generator and attached this Ugrinsky wind turbine to it. Now it's busy generating, as you can see, and I can't see that. I'll have to see that when I review it. It's not windy enough outside, so I've got a fan on it. The fan is about 3 meters per second. So we've got this generating away now. And what I want to do is show you exactly how I did that. Okay, so I need a length of this, which is drain pipe, my generator, and of course our pre-made Ugrinsky. We've made this before and used this a few times, so I've just picked it up. Remember, the Mite is made out of 3 parts. 2 coils like that, which are the stators, and then the rotor, which is just a plastic disc with some magnets on it. And what I've done is taken a bit of this tape, wrapped it around there until it's thick enough, and then it will just, literally just, there we go, fit snugly in that pipe. Now the tape has a little gap. That little gap is so that I can wire these up in series and drop a couple of wires out the bottom, because that's where we're going to collect it. So we put that in there. There we go. Then we'll drop the rotor in, and then we'll put that in there. Once we've sized it up, we need to solder the wires together so that in series so that we can get the output. I suppose we don't have to, we could take the output separately, but I'll do them in series. Okay, that's it shoved in its bit of pipe. Now, I just put a bit of glue in there to hold that temporarily, because I want to do other things with the Mite, and I want to do this as a temporary demonstration. If you wanted it permanent, then obviously pour a bit of resin in there and let it turn, and it'll be permanent and waterproof. And just in there are the connection wires, so we can just clip onto those connection wires so we can get an output from it. That's it finished. What a breeze. The only thing we have to do now obviously is put our Ugrinsky turbine on, and that just slides straight on there like that.
and then we're ready to go. Okay, I can't see what voltage it is. I'll have to check that out once I review the video. But there we go. There is our Mite wind turbine. It gave a pretty amazing result, 120 volts or so out of it, and that looks astounding. But just to warn you before getting carried away with something like that, it's only surprising at the first instance. Actually, it's completely understandable. The design of it, in fact, is not much different from this, which is it's a turntable motor from a microwave. And you see these quite often turned into little hand generators, and you'll get 40, 50 volts out of those. The reason is the wire is so thin. You've got to remember your Lorentz law, BLV sine theta. The length of the wire is absolutely huge in this, as it is in the Mite. There's a couple of thousand turns of hair-like wire on that from that great big spool that I've got. So it's no surprise that the voltage is high, because there's a huge length of wire in there. The thinner the wire, the more turns you put on, the more voltage you're going to get. So yeah, it got a high voltage, which is fantastic. Now the basic design actually isn't much different from this. This is the fan motor that's been kicking around and causing lots of stir, and it's not much different from this, which is a car alternator. It's the same arrangement. I have been told that this kind of generator was used by the post office in the 50s, 60s and 70s. I don't know if that's true or not, and even if we've reinvented it, I don't really care. At least we're thinking, and that's the point. The point is to be thinking. Now, the magnets and the magnetic field is bent 90 degrees by the bolt, and so it's got a 90-degree field. Remember, sine theta of 90 is 1, so it gets a huge amount of the actual magnetic field intersecting the wire, which doesn't happen in a standard motor, because a standard generator, as it rotates, at the top, sine theta 0, there's no generation. 45, it's 0.8, so there's only 80% generation, and then when it gets to 90, then it's at 1, so it's all generation, but you lose a lot of generation just because it's rotating. This one, of course, is bending the field, and it's 90 degrees all of the time, so it's no surprise that it does quite well. Lots of wire, 90 degrees, we rotate it. I mean, with the drill, we're only rotating about 300-400 RPM. If you rotate it a few thousand RPM, then of course it's going to generate a lot, because it satisfies the Lorentz equation. It plays on those ideas that are needed in order to create a generator. However, remember, sitting here, it does nothing. It won't generate anything until I spin this, because a generator converts mechanical energy into electrical energy. So if this is giving out 120 volts and I'm only putting a few watts in, you can guarantee the output is going to be in milliamps, because you can't get more out than you put in, and we're gonna get losses because it's a machine, so it's going to be in the milliamp range. We know it's gonna be that just by following the laws that we have that describe the behavior of these kind of devices. So the only win on this device is it was a piece of cake to make. And that's the thing that I said in the video. The whole point of doing it like this is because it's easy to make. Anybody with a pillar drill can make this, and that's the whole point. The wooden one we did, which is right here, anybody with an ordinary drill can make this, and those are the points of these generators. These generators can be made super easy at home by anybody with an absolute minimum of tools, and that is what I think is the real win. In terms of efficiency, well, it was surprisingly good, actually. I was quite pleased with how efficient it was. In terms of its output, if it's giving out that many volts, it's going to be giving out very few amps. Why? It's a generator. It converts mechanical energy to electrical energy. The input is always greater than the output. So I put a few watts in there. Overall, I'm going to get a few watts out. It's going to generate nice voltage that you can do something with, but it's not going to generate more than we put in. Now, having said all of that,
The Mighty Mite actually, apart from being easy to make, is, I think, a very pretty design, and we can do something with this super easy, because one thing is it's circular, which means we can put it in a bit of pipe. So this thing, the dimensions of this thing are 53 centimetres there and 18 centimetres across there, and a wind speed of about 3 metres per second. The mechanical power available that this can capture is in the region of half a watt. That's just the way it is, given the wind speed and given the size of this thing. That's all of the mechanical power that is going to be captured by this device. And that's true pretty much of any wind turbine design. We put it into this. We have half a watt going in. We must have less than half a watt coming out. Given that we generated about, what, 50, 55 volts, something like that? We'll be talking at something around 7 or 8 milliamps is what's going to come out of there. Now, don't let that depress you. No generator will do any better. The whole point of this is this can be made from household materials by anybody with a drill or pillar drill, and that's it. That's why I think it's awesome, because anybody can make it from scrap. That's the whole point of it. You can make it cheaply, you can make it from reclaimed parts, you can scavenge wire to actually make it. This can cost you pennies to make. And that's what I think is the real win. It's not any better generator than any other generator. It's a generator, and that's the way generators are. Now, people often use that as an excuse for wind not being brilliant, and that's actually because they're not really thinking it through. Wind is one of the cheapest renewables you can get. It has its disadvantages, yes, like everything, but then solar has huge disadvantages in that you can't actually make it. You can make wind, and it is, even when made and bought, one of the cheapest forms of renewable energy generation, so it's a lot going for it. Wind is proportional to the speed of the wind. 3 meters per second is peanuts. We get much more speed out of it, get much more generation, so it's not something to get depressed about or to get on your high horse to say that solar is so much better. It isn't. And the thing is, we can make this stuff. The big hold-up, I think, is being able to make this. The big benefit of the Mighty Mite is anybody can make it. Anyway, hope you enjoyed the video. Thank you very much for watching. And please do remember to like and subscribe.